you need to learn how to subnet. I don't know the reason why, but that's why you're here watching this video. Or I would assume it is. I'm going to teach you the way that I learned how to subnet when I took my CCNA the first time. It works for every octet. It's a pretty simple process. You can use this method until you just automatically memorize some of this information. But until you get the memorization down, which might take a few, I don't know, depends on how often you're subnetting, might take a while for you to memorize it. Well, if you stick with me through this video, you're going to be able to subnet in every octet and pass whatever exam you're studying for, as long as you're allowed to have a piece of paper and a pencil, or a whiteboard and a dry erase marker, which you are allowed to have that during the CCNA and the Network Plus. So I hope you enjoy this video. I hope you learn a lot. You look like you're ready to learn today, so let's get started. The first thing I do is I write down my powers of 2 down the right-hand side of the paper. This will help me determine the number of network bits or host bits that I need, and it also helps later when identifying the block size. Now, I'm going to start at 2 to the power of 1 and move down this column with 2 to the power of 2 and so on. Then I'll write in the values. 2 to the power of 1 is equal to 2. If you remember 2, 1, 2 in the upper right-hand corner, then that'll help you from getting messed up and maybe starting at 2 to the power of 0, which can just throw your table off a little bit. All right, you need to double each number as you go down. Do not count by twos. That is a very common mistake. We are doubling each value. So we start with 2 and then 4, then 8, 16, 32, 64, and 128. Now across the bottom, we need a set of lines that represent 8 bits. 8 bits because that is how many bits are in each octet of an IPv4 address. When I start assigning place values here, I begin with 1 on the far right-hand side. This is technically 2 to the power of 0, but for our chart purposes, there's no need to write down 2 to the power of 0. As we move to the left, we simply keep doubling the values again. This section of the table helps you determine how many network bits or host bits you need for any given problem. Now across the top, I'm going to draw some boxes. These numbers represent cumulative place values, starting from the left and adding values as we move to the right. For example, in the first box here on the left, the only place value is 128. So we simply write 128. In the next box, we now have 128 plus 64, which equals 192. In the third box, we have 128 plus 64 plus 32, which gives us 224. We continue this process as we move across to the right. I'll add 16 to get 240, then 8 to get 248, and 4 to get 252. If you are only subnetting in the 4th octet, you can technically stop here. But you may as well write the final 2 values as well, because this table will then work for subnetting in any octet. What do we use these numbers in the boxes for? These values give us our subnet masks and help us determine the block size. At this point, the table itself is complete. A couple of additional things you may want to write down are the formulas used when subnetting based on number of hosts or number of networks. They're pretty simple. 2 to the power of h minus 2 equals the number of hosts. 2 to the power of n equals the number of networks. We use these formulas to determine how many host bits or network bits we need in the subnet mask. The H in the first formula stands for host bits. Host bits in a subnet mask are always represented by zeros. In the second formula, the N represents network bits, and network bits are represented by ones, our only other choice. Now the fun begins. Here's a typical CCNA subnetting practice question. You're given the network 192.168.10.0/24. The network administrator needs to create 6 subnets, each supporting at least 25 hosts. Determining the following for the third subnet. They never start on the first subnet. That would be too easy. You need the network ID, the subnet mask in decimal and slash notation, first usable IP address, last usable IP address, and the broadcast ID. Okay, they're not going to ask you this specific question on the CCNA, or probably even one that asks for all of those items. But here's the thing. If you can solve all of those, you can answer any subnetting question. First, I'm going to handle the host requirement. So we need at least 25 hosts per network. So I'm looking over here in my right-hand column for where my formula is going to work for that. And if I look, 2 to the power of 5 here, 2 to the 5th, is 32. So 32 minus 2 is 30 usable hosts. If I go down to 2 to the power of 4, I won't have at least 25. So that's not going to work. Now, the thing that I can do now is just use this 5 here, my 5th, 2 to the 5th. So if I use the 5 here for my host bits, which are zeros, I can just write in 5 zeros. And here's my 5 zeros. And then what I have remaining on the network side here is 3 ones, because ones are network bits, and I've used up 5 spaces. I have 3 remaining, so I'm going to fill those with ones. This is going to work for my host bits. Let's just double check this requirement meets the number of networks. It will, I'm sure. They usually don't mix these up, but let's take a look. Let's just plug this into our formula for network bits. So we have 3 ones, so 2 to the 3rd, and that gives me 8, which is enough to cover the 6 that we need. So that does indeed work as our subnet mask. So if we just use our table here, we can see 3 ones, which is a /27, because we have 24, we have 255, 255, 255, and that equals 24 bits in our subnet mask, right? Because we have 8 bits and 8 bits and 8 bits, which 8 plus 8 plus 8 equals 24. So then I need these 3 more in the last subnet. That's 24, 25, 26, 27. And you can see now I know what my subnet mask and the slash notation are for it, just from putting those numbers in my table. I have /27 and 255, 255, 255, 224. Okay, now let's list the subnet network IDs. We can do this with a block size. I like this way the best. always are going to start here at network 0. So we'll start at 192.168.10.0. To figure out block size, we can just look again at our subnet mask, and the interesting octet in our subnet mask is the one that we're modifying. And that's our last octet here with 224. So I can just subtract 224 from 256, and that gives me a block size of 32. If I add 32, the block size, to the interesting octet of the IP address, then that gives me all of my network IDs, really, for all 8 networks. So the third network ID is 192.168.10.64. Well, what we really want to do is we want to calculate just past the third network ID here, because we need to also know the broadcast for this network. So we'll just go one more, and that gives us, 192.168.10.96 for the fourth network. So now that we know our fourth subnet ID, we can just subtract 1 from that, and that gives us our broadcast for the third subnet. We subtract 1 from that, and that gives us our last usable IP address. And then, of course, we just add 1 to 64, and that gives us our first usable IP address in that range. Our broadcast is 192.168.10.95. And so you've got your usable range here. And that's the complete subnetting solution. So you can really, if you're given an IP address in any one of these networks, you can say what network it's in. If you were given a number, if you were given some numbers in a network and it says which one of these IP addresses is correct, you just figure out your subnets just like this, and then you can see which IP address doesn't belong. Maybe we'll play that, like one of these IP addresses doesn't belong here. Oh my, I'm singing. That's from Sesame Street, by the way. So maybe we'll do that. We'll see. I hope this was helpful for you. If it was, then we're winning. Practice this many, many times and get your subnetting down for that CCNA.